Okay, what do you think about this one?
Well, I mean, isn't just -7/8?
Yeah, in this case, direct substitution works. There's actually a point there when you plug it into the function.
Mm.
So the limit's going to be the point. Okay.
Biggest factor at the top would be 2x plus 5x minus 1 over 1 minus x. Wait, should I just try and make 1 minus x a factor so I can cancel it?
Yeah, they can be, but there's a difference. How can you rewrite 1 minus x? Well, it contains an x minus 1.
Negative x plus 1?
Well, that's still, okay, you can rearrange it. Is there anything else? But notice that's still different, right? Because it's a plus 1. Do you
Yeah.
know how you can get an x minus 1 to appear by rewriting this?
Oh, by rewriting the denominator. Oh, multiply it by a negative sign?
So you don't want to multiply because that changes the value of it. Notice that you have a negative x, right? And
Yeah.
you want to turn it into an x. You have a plus 1, but you want to turn it into a negative 1. So is there anything you can take out?
Negative 1.
Okay, so what's that going to look like then?
Negative, and then in parentheses, x minus 1.
Yeah, exactly. Anytime you see two terms that are kind of switched over with the negative, one's just a negative version of the other. Because you can just rewrite it by putting it back in the same order and taking out a negative, and then you'll get the same factor. But there's an additional negative.
You can plug in 1, I guess, and we'll get -8.
How'd you get -8?
Oh, I'm sorry, -7.
Okay. Yeah, it should be -7, right? This becomes negative 2x plus 5. Yeah, plug it in, -7. Okay. What do you think about this?
Do you factor it?
Why do you want to factor it?
Oh, well, no, if you just plug it in, you get 0 over -2. When x is going to -1, the limit's 0.
Yeah, it's just 0. Let me ask you this. What do you think? If I change this to a plus 1 on the bottom, then you would get the 0 over 0 case, right? So then in that case, you would have to factor. Do you remember how to factor the numerator?
Oh, no, I don't. It's
Notice that x cubed is a cube number. 1 is also a cube number.
you. Yeah.
You're adding them. So you can use sum of
Oh,
cubed.
yeah.
Okay. Do you
Was
remember
it-
what goes in the first part?
The first part's a plus b,
Yeah. What were those in this case?
x plus 1.
Yeah, it's the cube root of each of the numbers.
Then is it a squared plus ab minus b squared?
Do you remember the acronym that goes with the signs?
Oh, wait, no, it's
It's
a squared minus ab plus b squared.
yeah, it should be a SOAP, same, opposite, always positive. Okay, so what would that be in this case?
X squared minus x plus 1.
Yeah.
Okay.
Yeah, and then from here, right, then you can
And then-
cancel out.
Get x squared minus x plus 1. You can just plug it in. Get 1. You get 3.
Yeah, this would cancel out with this. And you just have x squared minus x plus 1 left. 1 plus 1 plus 1, 3. Good. Okay, that should be it.
This one is also a whole cage. You just get 0.
Right.
I'll just do the conjugate,
Yeah,
which is just 3 plus root 9, or root x plus 9.
yeah, exactly. Just the middle sign between the two. When deciding to do this, remember, it's not just 0. It has to be 0 over 0.
Yeah.
Both the numerator and the denominator has to be 0.
0. If you multiply that,
Let's see, 9, and then you're gonna get minus x minus 9. What's the sign with x?
negative? No. Wait, in the denominator, positive.
Well, notice it's you have a negative root x plus 9 times a positive root x plus 9.
Oh, so it's negative x plus 9. So it's 9 minus negative x plus 9.
Okay, and so are you saying it's going to be like this?
Yeah.
You have to be careful because if you multiply root x plus 9 by root x plus 9, you get x plus 9, right?
Yeah.
But then what's the overall sign?
Oh, you get negative x minus 9.
Yeah, so this has to be in parentheses. And then
Okay,
it
so
becomes negative x minus 9.
you just end up with negative x on the bottom.
Yeah.
So it's 2x times 3 plus x root x plus 9 over negative x. And then, well, the negative x can't really cancel out with 2x, can they? Or you can do,
Well, the factors, right? You have a negative x
yeah. So
and a factor of 2x.
would that just leave you with negative x on the top?
Well, you have x over x here, right?
Oh, so negative 2.
Yeah, because the idea is to try to cancel out the factor that's causing the 0 over 0 part, right? This x over x thing, that's what is the 0 over 0. That's what's creating the whole.
Yeah. So we got negative 2. And then you can plug in the 0,
Yeah.
0, and you get 9. And you get, in the parentheses, you get 6 multiplied by negative 2 is just negative 12.
Right.
I'm a denominator on the top. 3 minus x minus 3 plus x over 3 plus x times x.
Okay, is this what you have in the numerator?
3 minus x minus 3 plus x.
You have to be careful of this overall negative. What are you actually subtracting?
You're subtracting x from negative x.
Yeah,
And negative
exactly.
2x.
And then you're subtracting 3 from 3, right? So if you subtract an x from negative x,
You get negative 2x over 3 plus x, 3 minus x.
yeah. So this should be in parentheses if you had that, or if you change the sign.
Yeah.
Because you're subtracting a 3 plus x overall, which becomes minus 3 minus x. What's going to happen then?
We need to make the denominator, like, somehow flip it, because the denominator can't be 0. Can you just multiply by the inverse of x? So you multiply the numerator by 1 over x?
Yeah, exactly. You can, since dividing by x is the same as multiplying by 1 over x. That's how you can get rid of the complex fraction.
Negative. That's where
Yeah,
x
numerator, right. Is this what you have so far?
Do you want to actually multiply it all out?
You shouldn't need to. Remember, the goal is to cancel out what's causing the 0 over 0.
Yeah, and you can't have it being multiplied by an x, right? Because that's just going to always make it 0.
Yeah. What's causing the 0 over 0?
You cancel the x's, you get negative 2 over 3 plus x, 3 minus x.
Yeah.
And then from there, you can just do, I guess, negative 2 over 9.
All right, you can plug in. I think the key step is just to know that if you want to get rid of the complex fraction, just move the overall denominator, multiply by its reciprocal. That'll get rid of the fraction over a fraction.